What we're going to talk about here is basically how not to build a distributed monolith. Um, and we're gonna talk about this here. This represents, sort of a simplified version of a distributed enterprise system. We've got on the top here are hexagons represent various applications that have internal state, right? And then we've got external event sources that might be publishing into our system, and we have various downstream event processors that are consuming events, all on some sort of distributed bus, right? So this is a classical EDA event-driven architecture. And we're going to talk about how things need to work on the inside and the outside to make this work. And by the inside, I'm talking about what's inside these application blocks here, right? A lot of this comes from a really great paper written by Pat Helland from Microsoft Research. I would heavily recommend everyone to go and read it, do their own research. If you just search for data on the outside versus data on the inside, it'll pop right up. There's a link there to a PDF for the paper. It's readily available. So I'm going to start by defining data on the inside, and then we're going to talk about the real question about data on the outside and the separation that requires. So what is data on the inside? It's your application's source of truth. It's a private data store or state store. It's got to be able to version and change with your application. So version 1, version 2, version 3, you're going to want to have control over what's in there. You're going to want it to be local or localish or close to your application. In a truly distributed system, that might mean in the same geo. It might mean the same availability zone. It might mean on the same machine. But we're not talking about something that we're going to make a remote call to the other side of the planet to update our state every time. That's not data on inside. That's not our local source of truth. And it's going to generally have a set of third normal form sensibilities. You're not going to want to repeat yourself. You're going to have sparse events. What does that mean in this kind of system? The best approach for that in an EDA architecture is to have on the inside an event-sourced application pattern of one of these types. And I'm going to actually recommend here that event sourcing is the approach you want to use for your application storage on the inside. All right, this is a Turing machine, which is the fundamental writer pattern that we're going to be talking about here. And we're going to use that to understand those 4 patterns and what the differences are. I'm going to run through this a little bit quickly. I'm sure some of you have seen this before, but I want to make sure that we're clear on what we're talking about on this side, because it'll help us define what's on the outside. So for saving commands, that's command sourcing. That's going to have some interaction with the version states. That's not really what we want to do for our application OLTP or OLEP source. Internal state, this is changing a capture or state logging. Again, this is tightly coupled to each of our individual services. It's going to make it hard to version everything, and we're going to lose a ton of relevant information. So what we're really talking about here, data on the inside, third normal form, events, is the output, the business decisions of your services or your writers. Those writers could be aggregates, they could be microservices, they could be anything. They're just a state machine that reads history and reproduces a decision. For this, we're going to start defining now a business schema on top of that. So we're going to have a business-defined schema that is local to the context or the domain of our application. You should be able to read that log with a domain expert for that application scope on the inside without knowing any of the services. Right? Application decisions persist as an immutable sequence of business events. This is how it's going to break down internally, fine-grained streams in one master log. Writers are restricted to one stream. Readers read from everything. Right? We want this data on the inside to be sparse. We don't want to do hierarchy and table. We want everything to be clear, simple tuples. And we're going to model our process history, not our current states. Application is going to use surrogate keys. We're not doing display data. What you use here matters. This is your durable long-term state for your application. That application might be a set of microservices, all producing one result. It could be a legacy monolith. The key points I'm going to say here, we want database guarantees. We don't want something that's going to go away. This is our historical state, right? The positional queries are going to be important, and the sequential numbering are going to be important later on. Now let's get to data on the outside, right? It's a shared source of truth. We want to be able to regenerate data from this. We want to have stable versions. So while I want to be able to iterate my application 5 or 6 times on the inside, I want external consumers to not have to worry about how many times I've updated or pushed this. So I'm going to need a schema version that doesn't change. I'm likely going to have multiple versions of the schema in production at the same time. The schemas that I'm going to want here are going to be coarse-grained. We don't want downstream consumers to need to call back. It's more of a first normal form sensibility. So here, and so sometimes there's resistance about this. If we take a look here, this writer is going to be doing the third normal form data on the inside, and we're going to explicitly do a transformation, that's an anti-corruption layer, to create a public event that we're going to share with the downstream systems. Worst case, I would say, if you don't know who's downstream, do coarse-grained state events and just have a default schema. Never share any private internal events with the public bus. As soon as you share anything, people are going to start taking dependencies on it. Once they've started taking dependencies, if you change your mind, you're going to start breaking them. If you're lucky, you'll know you break them right away. But if you don't, all of a sudden you'll get subtle defects long term once you've got lots of data corrupted and persisted through your system. So it seems like extra work, but it's really not. It's the same data modeling we would do in any relational or any other system to have this consumable schema. And we're going to do that in a way where we're going to design that public schema, right, by the consumer. So the rules are, have a public schema. Never publish your private data. That is the route to turning all of this into a distributed monolith. And distributed monoliths are way worse than regular monoliths, because you get all the problems of the monolith and all the problems of distributed systems together in one ugly little package. So consumer-driven design on what needs to get published. Consumers should not need to query or aggregate data in order to operate. What that means is if I have an invoice processing service and I'm updating an invoice, setting line items on that invoice, if I'm publishing that invoice, so if we got two ways I could approach this. One, I could keep that invoice secret inside my system until it has been approved, and then publish that public invoice out to everything else for something else to process it, a payment gateway, an email system, something along those lines. Or I could publish intermediate updates on that invoice every time a line item changes. If I do that, the event that I want to publish wants to be the entire invoice, even though it's going to duplicate from the last one. Don't do a delta. Do the full invoice every time with an incrementing sequence number on each time you publish that. Expect these schemas to be long-lived. Expect to have multiple versions. All it's going to mean is you're going to have variations of this ACL, and you have multiple ACLs that are each publishing different versions of the schema. The other thing that's important is we have to separate that the internal data is a source of truth. All external data sources should be able to be regenerated. They are all derived state. Unless it's something being consumed by another application, turns that into its source of truth, it's going to be able to rebuild them. In practice, we're going to have intermediate caches. We're not going to rebuild from zero. We're not going to process 1 million events, but we need to be able to. The design standards you could, practical systems shouldn't have to. The update should form an acyclic directed graph with the source of truth at the root. What that means here is one-way updates. Yes, source of truth event to source of truth. So primary data, derived data, output. Do not publish and have multiple systems updating from the publish. Everything needs to be one way. You can have as many branches as you want, you can write as far as you want, but one way, start at the top, work your way out. The other large question I get is replays. What we want to do is we want to publish to the log from our service. We want to consume from that log, but if you are restarting that service, starting a new one, failing it over, you find missing messages, have a direct query link to that application in order to get current state. Do not respam the universe with all your old messages just to reset this service. Post-ordering. Sometimes you want an order for some downstream consumer, like a reporting service, doesn't have any internal order. Global ordering is going to be limited to the applications, but we can take the output of those applications, order them in a downstream store after the fact, and then have consumers consume the ordering information in this downstream store. That downstream store doesn't need to copy all the data. It only needs to guarantee the ordering so that all replays follow the first delivered ordering. That's called the post-ordering pattern. So that was my 15-minute lightning talk on large-scale system design. Now available for any questions.